All right. Start out with any questions. Hope.
So on one of the tests, it asked for like situations with speed, velocity, displacement, like one's constant, one's not constant, okay? This one we couldn't figure out. The displacement or the change in speed is constant, not zero, and the velocity is not constant. We know that it's not possible. Correct. But we don't understand why.
All right, so displacement is where an object is relative to the starting point.
Correct.
The starting point there, and let's say that we're here. So we started here, we end up over there. So that's my displacement. It has a magnitude and direction. It is a vector quantity. If that is constant, what does that tell you about? What does constant displacement tell you?
It's not moving.
Right. If I am anywhere else besides here, then my displacement is different because it has either a different magnitude or a different direction or both. So constant displacement and just like constant position both mean that you're not moving. And the other half was that velocity is not constant, which means that even though velocity could be zero for a brief moment, it would not stay there. The velocity is changing. And so if velocity changes, that means that you're moving, that's at least at some point, which means that displacement can't be constant.
Can't be constant. Okay. Easy enough. Thank you.
You said displacement is not constant and velocity is not constant?
Displacement is constant.
Displacement is constant.
Yeah.
For number 9 on the fall 2012 test, it asks which of the following can never be simultaneously true, and I'm confused at why D was not in.
So speed is zero, acceleration is constant. All right. If I throw an object straight up into the air, ignoring air resistance, what are the forces acting on it after it's left my hand?
The gravitational force.
Okay? And by the way, the force from my hand expires as soon as it leaves my hand. So the object goes up. The only force acting on it is the force due to gravity, as you said, the weight. So I have an object where the weight is acting down. Because the weight's acting down, it'll slow down as it goes up, it'll speed up as it comes down. So my velocity initially, if I say up is positive, my initial velocity is positive, it gets to here, and then my velocity is negative when it's on the other side, or when it's coming down. You can't go from positive to negative without passing through zero. So at the very peak, the speed is zero, but there's still a net force acting on it, there's still acceleration. So as long as the weight remains constant, the acceleration remains constant. So it is possible for speed to be zero and acceleration to be constant. Acceleration to be constant. Is that, okay.
Actually, never mind. Answer the question. I said never mind. I just realized the answer.
Okay. Glad I could help. Deanna?
For this one, it's a 100-gram beam. Could we go over that one?
All right, so. That was the summer test. The interesting thing about that one is the number of students who skipped it. They missed it completely. I remember that because when I was writing out those solutions, I skipped it also.
Oh, well, let's hope that happens.
Yeah, I'm still trying to figure out why visually it was so skippable.
I don't know. Maybe it's
Alright.
because all the other ones have so many parts.
That would very well be. All right, so we have a 100-gram beam. First off, what does that tell us?
It is 100
It's
grams.
mass.
That I was looking for the type of quantity. Yes, it is indeed. It is the mass. It is not the weight of the object, which would be 0.100 kilograms. Let's see, supported at its center of mass, 56 centimeters from one end. So we got 56 centimeters, or 0.56 meters. So that's the center of mass, so we treat the weight as it's acting right there. And 67 centimeters from the other end, okay, so not to scale. So that sentence right there is basically telling you the length of the beam. A 70-gram mass is placed on the beam 32 centimeters from point A. So one end, so this is point A and that's point B. 70-gram mass is placed 32 centimeters from point A, so here we have a mass sitting on it. And this mass right here is 70 grams, or 0.070 kilograms. And our mystery object was placed 20 centimeters from point B, so I have another object over here with some mystery value x. What is the mass of the mystery object? Oh, okay. Yeah, this actually is a question that goes along with chapter 7, oh no, chapter 8. Because I didn't give enough information for it to be in chapter 2 through 5.
So we won't have a question for that.
Let's make sure I didn't miss something. 100-gram beam sort of the center. Yeah, this relates to a lab that we did that summer. And so the essence of it is that the weight, since it's being supported at the center of mass, ultimately it's this distance times the weight of that should equal that distance times the weight of that. It's a rotational equilibrium problem.
But that won't be on.
No,
the
no,
test.
that is beyond the scope of the way the course is structured now.
Okey-doke. That's relieving.
But it was directly related to a lab that is now part of chapter 8 instead of chapter 2.
Okay.
Anything? Yoha, you look like you have a question.
I have a question, I would just let you take it. How is that,
Number 13, object starts the problem at a position of 2 meters. Object is moving. After 4 seconds, the displacement is 3 meters. It stays at 3 meters for 6 seconds before moving to displacement of 0 meters. And it stays there for 1 second before moving to, okay. So draw all right, so we have, it's starting at 2 centimeters, or at 2 meters, that's the starting point. And it's moving, so this is at time 0. After 4 seconds, at 4 seconds, it is at 3 meters. And it stays there for 6 seconds. So at 10 seconds, it's still at 3 meters. Before moving to its displacement of 0 meters, then it goes to 0 meters. And there's a missing time there, which I wrote on the board when giving this test. And it stays there for 1 second. So 1 second passes. And then it goes to -4 meters, again, another time missing. And it's there for 3 seconds. So let me fill in the 2 gaps there, or let me read it again just to make sure I didn't forget something. Object starts at 2 meters and it's moving. After 4 seconds, it's at 3 meters. It stays at 3 meters for 6 seconds before moving to 0 meters. It stays at 0 meters for 1 second before moving to -4 meters, where it stays for 3 seconds. So let's assume that it took 1 second to move from 3 meters to 0 meters, so that puts us at 11 seconds total, then 12 seconds to get to there. And so this would be 15 seconds. It's just a matter of stuff was missing and that you have it now, or do you want to keep going?
We'll keep going.
Okay. So the first question was plot position versus time, and the next one is plot velocity versus time. So I have the problem taking place over 15 seconds, so let's mark that out. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 5. 15, so this is time in seconds. My position, the highest position is 3 meters and the lowest is -4. And so this is position in meters. So 1, 2, 3, -1, 2, 3. And so I give specific locations. I know it starts at 2 meters, right there. At 4 seconds, it's at 3 meters, so 4 seconds and 3 meters, so I plot that point. And it's moving. I am assuming that it's moving at a constant velocity there. It is at 3 meters for 6 seconds. So that flat lines. And then it goes down to 0, and I added that in 1 second. So that's supposed to be straight. It's there for 1 second. And then it goes to -4. And I added that takes place in 1 second. And it stays there for 3 seconds. So that is the solution given the additions that I gave. Now velocity, this part B is when it's asking for velocity, it's basically looking for slope. So if I think about these first 2 points here, slope is rise over run. So what's the rise?
1.
And what's the run?
4.
So for the first 4 seconds, my velocity is 1/4 meters per second, or 0.25. I think I'm going to run out of room there. Yeah, especially if that's at 1 second. So what I'm expecting to see here is somewhere around 1/4 for the first 4 seconds. Basically, velocity is a positive 1/4 meters per second. This is time in seconds. And this is velocity in meters per second. From 4 seconds to 10 seconds, what's the slope of a horizontal line?
0.
Because there is no rise, since it's rise over run, there is no rise, the run is 6. So it's 0 divided by 6, or 0. And so at this point, it's 0 until we get to 10 seconds. Then from 10 to 11 seconds, I'm dropping quickly here. My run is 1 second. What's my rise? I heard the negative part. That's the key thing that I think if anyone missed anything, they missed that. So I dropped 3 in 1 second, so my slope is -3. somewhere around here. And then my slope,
Zero.
and then what's my slope for the last bit, or for this section right here?
-1/4, or no, -4.
-4, because again, I'm dropping 4 in 1 second, so my rise is -4, my run is 1, so my slope is -4. And then it goes to 0 again. So that's basically what the graph would look like. And as commented, I know I made the comment to some groups, I don't know if I made it to the whole group, but if this were actual reality, you would not have these sharp points here, because this sharp point means that on one side I have a velocity that's not 0, on the other side I have a velocity that is 0, and the slope of velocity is acceleration, and that's an infinite acceleration. That would kill you. Yeah, that would kill you even more if you got that far. There was a book, Hyperion, the Hyperion series, in which they basically, if you wanted to travel at incredibly fast speeds, at the end you basically were a bowl of mush. But there's a creature that was living on you that would reconstruct you. But they took into account the fact that stopping quickly reduces you to basically a puddle of what you're made of. A nice little upbeat anecdote. Other questions?
I have another question.
Okay.
Okay, this one is forces acting on a box, and if the forces shift, what would be the maximum and minimum force?
Okay.
I don't really understand that.
So, I think in essence, you have, I think, 2 forces starting out on it, or I have 2 forces.
2 forces, 40 newtons east and 30 newtons north.
40 newtons and 30 newtons. So the net force on this is 50 newtons at an angle of 37 degrees. So if I want to know what the sum of the forces is here, because they're at a right angle to each other, I have 40 newtons this way, add 30 newtons this way, and then my resultant is from where I started to where I ended. Because that's a right angle, Pythagorean theorem, you'll end up with this being 50. It's a 3, 4, 5 triangle. So the magnitude of the resultant is 50 newtons. This angle right here is beyond the scope of what we need to do for this course. But the question was, if the forces shift, what's the maximum? Well, think about it. You have 2 people who are pushing on a box. Right now, they're pushing at a right angle to each other. But if there are 2 people pushing on a box, how would you get the most bang for your buck? If you're
If they teamed up,
teamed up in what way?
You just added them together.
Okay. So if they pushed in the same direction, so it shifts, you'll get the maximum of 70 newtons. And then what would be the least productive?
if they oppose each other.
Yes. So the minimum would be if they're going against each other, so it's 10 newtons.
Alright.
I think that was on a master set, wasn't it? Or,
Yeah,
okay.
that one.
All right, while she's looking, anyone else with a question? Brianna?
Could we do one of those, the box and the ramp and the acceleration, velocity and position thingamajiggers?
Okay. You're
Those
looking at one in
right there.
particular?
Oh, well, that's the solution. This is I feel like I get everything but the acceleration portion of it.
Then that's the toughest one.
This
Didn't even have a picture with that one.
Like, I feel like it was easier when it was like the the little shaded box, and you can just put in the shading or the little plus or negative, but I feel like I don't quite understand.
Well,
Cause I have to see it.
I have to.
so it's this format of presentation that's messing you up?
Yes.
Okay, yeah, well, I mean, this 2013, that's what I did. The past couple of years, I've given the 4 choices.
Oh.
So, yeah, so if you don't understand this notation, then don't
So
worry
on
about
the
that.
test, I have the option to do,
Oh, yes, you have the option of shading in the boxes or putting plus minus 0 in the boxes or
perfect,
doing the bracket parenthesis notation.
love that,
Okay,
for me. But I would like to go over the acceleration portion, cause that
Okay.
part is so
Do you want the
iffy.
one off the master set though, with the way you like it? Cause I have it right here, if you want it that way.
Whichever. Doesn't
all right, I'll do this problem and then we'll present it in, you like the shaded boxes, we'll do the shaded boxes.
Cause I have the same question.
We do too.
All right. Any questions on this before I erase it?
What test is that?
This is the summer of 2013.
Summer community?
The first time I attended an online class. But I saw them for a while. All right, so let's see, boxes sliding on the level frictionless floor to the right, and then upper frictionless ramp. The box reaches a certain point on the ramp where it naturally turns around, slides back down the ramp to the level floor until it hits a wall. So I got a wall over here. Assume positive is up and or to the right, so basically if it's moving that way, it's positive. And negative direction is the other way. Assume position is equal to 0 at the transition between floor and ramp, so that's 0. And then I define A as the initial position on the floor. So that's A, the box is moving to the right. At B, the point at which the box transitions from floor to ramp. And some of the wording I did back then. All right, that's vague.
atrocious.
C, the point at which the box turns around.